This lesson is segments and rays. Here we're going to learn how to draw and name and label segments and rays. We will figure out distance on the number line, midpoints on the number line, talk about congruent segments. We'll do the segment addition postulate. So let's just get right to it here. Distance on the number line. The distance between any 2 points on the number line is the absolute value, that means it's going to be positive, of the difference between the real numbers corresponding to the points. The difference, we're going to subtract. Subtract one from the other and take the absolute value. So the absolute value of the difference of the two coordinates A and B, absolute value of A minus B. We do the absolute value because distance is never negative. That way it stays positive. And it doesn't matter the order that you do the distance. You could do A minus B or B minus A. And when you take the absolute value, the answer will still be the same. So, what's the distance between P and K? Well, the coordinates are the numbers on the number line. Capital letters are the names of the points. So the coordinates of points P and K are 3 and -2. P is on 3, K is on -2. To solve that, we'll substitute into the formula. 3 minus -2, absolute value of that, and that's a 5. The absolute value of 5 is 5. We could have also done -2 minus 3 if we had done that. The absolute value of -2 minus 3 is the absolute value of -5, which is still 5. So distance is always positive. When we talk about between, the definition of between, x is between A and B if the measure of segment AX plus the measure of segment XB is equal to the measure of segment AB. And you can see it in this diagram. X is between A and B. If you take the length from A to X, add that to the length from X to B, one part plus the other part equals the whole thing from A to B. Add up the parts to equal the whole thing. This is not when X is between A and B. Notice the distance from A to X to B, you're traveling a longer distance here. So if there's a bend, then X is not between them. On the left, AX plus XB equals AB. On the right, however, it's greater than. So we want the one that's equal to, where the first part of the segment plus the second part of the segment equals the whole segment. So we're talking about segments. What is a segment? That's a part of a line that consists of 2 points called the endpoints and all points between them. If you want to draw a segment, you draw it like this. Draw a straight segment there, put a point on each end, name it with a capital letter, and this segment could be called segment AB or segment BA. The order doesn't matter. You call this segment AB. If it doesn't have the segment bar on top, then you're talking about the length of the segment. So I would call this, where it's just AB, I would call that the measure of segment AB. However, if it does have the bar, that's segment AB. It's like if you have a pencil that's 5 inches long. With the segment bar, you would call it the pencil. Without the segment bar, you would call it 5. One is the thing itself, and the other is the length of it. The segment addition postulate. The definition is that if C is between A and B, then the measure of segment AC plus the measure of segment CB equals the measure of segment AB. The parts of the segment add up to equal the whole segment. So let's do this example. If the measure of segment AC is x, the measure of segment CB is 2x, and the measure of segment AB is 12, then find x, find the measure of segment AC, and find the measure of segment CB. So let's draw it. Sometimes it's not drawn. We need to draw it. So C is between A and B. Draw the straight segment with C somewhere in the middle of it. Doesn't have to be in the exact middle, but somewhere on that segment. A and B are at the ends. Label the parts. The measure of segment AC is x, so we'll put that between A and C. The measure of segment CB is 2x, so we'll put that here. And then the whole segment has a length of 12. So we'll put a little dash and an extension line there with a 12. Draw that extension line with another dash. That signifies that 12 is the whole length there from A all the way to B. So now I can see in the picture I have one part plus another part equaling the whole thing. And that's what my equation will say. I will say, first off, I can speak in terms of the segment measures. The measure of segment AC plus the measure of segment CB equals the measure of segment AB. And now I can substitute in the values. AC is x, CB is 2x, AB is 12. And now you have an equation that you can solve. We'll solve for x. X plus 2x is 3x. I'll combine those like terms. Divide both sides by 3. And x is 4. That's my first answer. It also wants the measure of segment AC. Well, the measure of segment AC is x. So if the measure of segment AC is x, then AC is also 4. And it wants the measure of segment CB. Well, the measure of segment CB is 2x. So the measure of segment CB is 2 times the x, which is 2 times 4, and that's 8. So look at the information they give you, draw it, label the parts, each part, and then do your extension lines here to do the whole thing. Part plus part equals whole thing. Substitute the values in, solve, and then find all the pieces that they ask for. Congruent segments. Congruent segments are segments with equal lengths. And the congruent symbol is this. It's like an equal sign with a little squiggly symbol over top of it. That means congruent. When you have congruent segments, you mark them with dashes, just like that. If segment AB is congruent to segment CD, we'll put a dash on each one. If the numbers are equal, then the objects are congruent. This is segment AB, and this is the measure of segment AB, which is the distance from A to B. The top one is an object, the bottom one is a number. So if the objects are congruent, then the numbers are equal. You would say AB equals CD for the numbers, or you could say segment AB is congruent to segment CD. These are the objects. You don't say that AB is congruent to CD or that segment AB equals segment CD. This is the wrong way to do it. Without the bar, use the equal sign. With the bar, use the congruent sign. Now let's talk about midpoint. A midpoint is a point that divides a segment into 2 congruent segments. In this picture here, If segment DE is congruent to segment EF, then E is the midpoint of segment DF. You can see that it's marked with the congruent dashes there. If you're on the number line and you want to find the midpoint, take the midpoint between 2 points A and B. The formula is, we write it in here, it's simply A plus B over 2. You add up the ends and divide by 2. The midpoint is like the average of the points. And when you take an average, you add up the parts and divide by how many. Add the 2 parts, divide by 2. So if we're doing an example on the number line here, let's find the midpoint of segment PK. Well, we know that P is at 3 and K is at -2, so add up the coordinates 3 plus -2 and divide by 2. That's a 1 over 2, which is 0.5. You could call that 1/2 or 0.5. They're both correct. And the midpoint is going to end up being, if m is 0, n is 1, 1/2 will be about right there. So right there is the midpoint. We'll put a point right there for the midpoint. A segment bisector. This is any segment, line, or plane that divides a segment into 2 congruent parts, and that's called a segment bisector. It cuts it into 2 congruent parts. The bisector does the cutting. It could be a segment, it could be a line, it could be a plane. So here, segment AB bisects segment DF. Segment DF is cut into 2 congruent halves. You can see them marked right there. Line AB is bisecting segment DF here. It could be a line also. Line AB bisects segment DF, and again, segment DF is marked with the 2 congruent parts. Our next vocab word is a ray. Ray RA. It has one arrowhead pointing to the right. This is segment RA and all points Y such that A is between R and Y. And you can draw it like this. Ray RA. R, which is the first point in the name here, that's the end point. And then draw an arrow and put A somewhere on that point, or somewhere on that ray. Ray RA. Or it's ray RA this way as well. You could have any other point on it as well. Point Y is out here somewhere. As long as point R is the end point and then A is somewhere on it. You call it ray RA, not ray AR, because A is not the end point. The first letter has to be the end point. This one, you could call it ray RA or ray RY, but not ray RAY. Don't use 3 points. So the first point has to be the end point, and the second point is any other point on it. So the symbol, this symbol here, you call it ray RA. Sometimes you have opposite rays. If A is between X and Y, then ray AX and ray AY are opposite rays. Opposite rays must have the same end point, and they form a straight line. You have the end points in the middle, and then It's pointing one way, maybe to the left, and then it's also pointing the other way, maybe to the right. They have to point in opposite directions though. This is opposite rays. Ray AX pointing left, ray AY pointing right, and they both meet at point A, which is the end point of each ray. These are not opposite rays because it bends. If they don't form a straight line, then they are not opposite rays. And if they overlap and don't have the same end point, then they're not opposite rays. Ray DE starts at D and goes right. Ray ED starts at E and goes left. And they end up overlapping in the middle. This overlap in the middle where they're both occurring, they're not opposite rays because of that. It has to start at one point in the middle and then go in opposite directions from that one point. So let's do some segment addition here. Remember, with segment addition, the parts add up to equal the whole thing. So this first one, we're looking for the measure of segment PR. Well, I know since Q is between P and R, then PQ, that's the measure of segment PQ, plus the measure of segment QR equals the measure of segment PR. I'll substitute in what I know and solve for what I don't. Measure of segment PQ is 19.4. Measure of segment QR is 3.7. And I'm looking for the measure of segment PR. Put these together. That's a 23.1. And I'm finished. So the measure of segment PR is 23.1. Add the parts up to equal the whole thing. On the second one, X is between W and Y. So I know then that the measure of segment WX plus the measure of segment XY is equal to the measure of segment WY. Measure of segment WX I don't know. Measure of segment XY is 10.4. And the measure of segment WY is 100. We'll subtract 10.4 from each side so we can get the WX by itself. And WX is equal to 89.6. The parts add up to equal the whole thing. How about this example? They tell you that we need to find X and the measure of segment KL if K is between J and L. So let's draw that. Let's draw K between J and L. K is between them. J and L are the ends. They give you these values. JK is 6x. KL is 3x. And the measure of segment JL is 27. So we'll put these extra dimension lines there to draw the whole segment length there. Now the parts add up to equal the whole thing, so let's do that. One part 6x plus another part 3x equals the whole thing, 27. Part plus part equals whole thing. Now solve. Like terms here, 6x plus 3x is 9x. Divide both sides by 9, and x is 3. That's our first answer. And they also want the measure of segment KL. So KL, they told us in the question, it's 3x, and x is 3. So 3 times x is really 3 times 3. KL has a measure of 9. So if it's not drawn, draw it. And draw it based on the way it's being described. K is between J and L, so put K between J and L. Label the parts with their measures. Part plus part equals whole thing. That's your equation, and solve. Don't just find x, because sometimes it asks for something else. If you find x and then stop, You're not done, because it also wants the measure of segment KL. So make sure you fully answer the question. Here, we need to find x and the measure of segment KL if k is between j and l. So let's draw that again. K is between j and l, so k is somewhere in the middle. J and L are on the ends, capital letters for those points. Measure of segment JK is 2x. Measure of segment KL is x plus 2. And the measure of the whole thing, segment JL, is 5x minus 10. So we'll put the extra dimension lines on the 5x minus 10, so it's obvious that it's talking about the whole segment. Now write your equation. Part plus part equals whole thing. First part 2x plus second part x plus 2 equals the whole thing, 5x minus 10. And we'll solve. Like terms here, 2x plus x is 3x. I can move the 3x to the right by subtracting it from each side. And since I moved the x's to the left, let's move the constants to the right. I have a 10 that's added. We will subtract it to move it left. Let's bring this up here, get more room. 2 minus 10 is negative 8. And the 10's cancel, leaving a 2x. Divide both sides by 2. And I made a mistake, didn't I? Oh, I did make a mistake. Let's correct it. This is a 5x minus 10. Let's fix that. That should be a minus right there. Let me get my eraser tool out. Hopefully I didn't confuse the whole world here. Yeah, let's back up a little bit. Hopefully you spotted that before that. So 5x minus 10, still 5x minus 10. It's still a minus 10, so to move a minus 10, it adds to both sides. Add it to both sides. 2 plus 10 is a 12. Now that makes more sense. And then leaving a 2x on the right. Divide both sides by 2, and x is 6. That's our first answer. And then measure of segment KL. KL is x plus 2. It's x plus 2, which is 6 plus 2, which is 8. So, draw it, label the parts. One part plus another part equals the whole thing. Solve it. Be careful. Hopefully you won't make a mistake like I did there. Hopefully you caught that and made your corrections. Solve for x, and then make sure you answer the whole question. They wanted x and KL. So that does it. We've done distance, midpoints, and segment addition. Segment addition we will use all the time, where the parts add up to equal the whole thing.